Hello and welcome to IITN Academy. In this session, we will learn about motion. A body is said to be in motion or moving when its position changes continuously with respect to a stationary object taken as reference point. Motion is a combined property of the object under study and the observer. There is no meaning of rest or motion without the viewer or reference. Let us see example below. A robber enters a train, moving at great speed with respect to the ground, brings out his pistol and says, "Don't move, stand still." The passengers stand still. The passengers are at rest with respect to the robber, but are moving with respect to the rail track. Passenger is at rest with respect to robber, but moving with train. For class 9, reference frame is always ground. Here, we will learn about position of an object in motion along a straight line. Position of an object is given by its location on the straight line. To locate an object means to find its position of an axis, such as the x-axis. For example, a particle might be located at x equals 2 meter, which means it is 2 meter in the positive direction from the origin. If it were at x equals minus 2 meter, it would be just as far from the origin, but in the opposite direction. Before we move, let us try this simple example. Find the position of an object from the straight line given below. It is simple. O is at 0 kilometer. C is at 25 kilometer. B is at 35 kilometer. And when it is at A, it is 60 kilometer. Here is the definition of displacement: a change from position x 1 to position x 2 is called a displacement. It is denoted by delta symbol. If a particle moves from position x1, which is at 5 meter, to position x2, which is 12 meter, then displacement is 12 minus 5, which is 7 meter. the positive result indicates that the motion is in the positive direction. If, instead, the particle moves from x 1 equals 5 meter to x 2 equals 1 meter, then displacement is minus 4 meter. The negative result indicates that the motion is in the negative direction. This is distance time graph. Here you can see mouse is in motion. It is starting from a position x equal to minus 5 at time 0. It starts moving on this blue path. At time t equals 1 second, it is at this position. Slowly and slowly, at t equals 3 second, mouse move to position x equals 0. After t equals 4 second, mouse move to a position x equals 2 meter. Now you have learned how to read this distance time graph. Here we will learn about difference in distance and displacement. The distance traveled by a body is the actual length of the path covered by a moving body, irrespective of the direction in which the body travels. But displacement is shorter distance between start point and end point. Let us see this example. An object start from A and reach O through two paths. First it goes to B and then to O. In second case, he directly goes to O. In first case, distance is 500 plus 400 equals 900 meter, but displacement is 300 meters. In second case, both distance and displacement is 300 meter. Distance is scalar quantity and displacement is vector quantity. Scalar quantity depends only on magnitude and vector quantity depends on both magnitude and direction. Here, we will learn about uniform and non-uniform motion. A body has a uniform motion if it travels equal distances in equal intervals of time. See the table. Object A. Travel 10 meters in every 15 minutes. Hence, this is uniform motion. A body has A. Non-uniform motion if it travels unequal distances in equal intervals of time. In this table, you can see object B. Travel 12 meter, 19 meter, 23 meter, etc. All are different for time interval of 15 minutes. Hence, this is non-uniform motion. You can see distance time graph of uniform speed is a straight line, while that for non-uniform speed is curved line. The motion of a body can be defined by three terms: speed, velocity, and acceleration. Let us study them in detail. The speed of a body gives us an idea of how slow or fast that body is moving. Speed of a body is the distance traveled by it per unit time. The speed of a body can be calculated by dividing the distance traveled by the time taken to travel this distance. Formula for speed is distance traveled divided by time taken. Speed is denoted by v, and it is distance, which is denoted as s, and divided by t, time. Let us solve one simple example to solve speed problem. A car travel 100 kilometers in 4 hours. Calculate speed. It is simple. Total distance is given by 100 kilometers and time is 4 hours. Hence speed is 100 divided by 4, which is 25, and unit is km per hours. As distance was is in km and time in hour. Here, we will understand average speed of a body. The average speed of a body is the total distance traveled divided by the total time taken to reach this distance. Let us understand this by an example. A car travels a distance of 100 kilometers in 2 hours. Its average speed is 50 kilometers per hour. The car might not have traveled at 50 kilometers per hour all the time. Sometimes it might have traveled faster and sometimes slower than this. Let us see the example for calculation of average speed. An object travels 16 meters in 4 seconds and then another 16 meters in 2 seconds. What is the average speed of the object? Total distance traveled is 16 plus 16 equals 32 meter, and total time taken is 4 second plus 2 second, which is 6 second. Hence, average speed is total distance divided by total time which is 32 divided 6, which is 5.33 meter per second. Odometer is reading of the car. Distance traveled by car is difference of reading of odometer. This problem uses this concept. The odometer of a car reads 2000 kilometers at the start of a trip and 2400 kilometers at the end of the trip. If the trip took 8 hours, calculate the average speed of the car in km per hours and meters per second. Distance covered by the car S equals 2400 kilometers minus 2000 kilometers equals 400 kilometers. Time elapsed T equals 8 hours. Hence, average speed is 400 divided by 8 equals 50 kilometers per hour. Convert this in meter per second. 1 kilometer is 1000 meter and 1 hour is 60 minute and 1 minute is 60 second. Hence it is 13.9 meter per second. Here, concept of unit conversion is required. A scooterist covers a distance of 3 kilometers in 5 minutes. We have to calculate speed in different units. We know the formula for speed calculation. It is distance travel divided by time. Easy way to solve this is convert units into required unit. First one is km divided by minute. We want meter per second. Hence, convert km to meter and minute into second. 1 kilometer is 1000 meter and 1 minute is 60 second. Now simplify this rational number and you get 10 meter per second. If you want centimeter per second, simply convert meter to centimeter. 1 meter is 100 centimeter. Similarly, for meter to kilometer conversion, 1 meter is 1 by 1000 kilometers. And 1 second is 1 by 3600 hour. Here, concept of unit conversion is required. Here, we have to calculate and compare speed of Two trains. Speed of train A is calculated as 120 divided by 3, which is 40 kilometers per hour, and speed of train B is calculated as 45 kilometers per hour. Hence train B run faster than train A. Here, we have to calculate average speed of a car. It travel 30 kilometers at 40 kilometers per hour speed, and next 30 kilometer at 20 kilometers per hours. We have to remember that average speed is total distance covered by total time taken. We are given distance and speed, hence time is calculated. For next part, we will calculate time for next 30 kilometers. Next, the car travels a distance of 30 kilometers at a speed of 20 kilometers per hour. We will also find out the time taken. Hence time is calculated. Now total time of the journey is calculated. Total distance is 60 kilometers. Hence average speed is total distance traveled by total time taken. In this problem, we have a train track of 120 kilometers. There are two parts of the journey, first part of 30 kilometers and second part 90 kilometers. First part is traveled at 30 kilometers per hour. We have to find out average speed of second half. Given is overall average speed of the journey of 120 kilometers. Let us start from time part. Total time of journey is total distance by overall average speed, which is calculated in next slide. Hence, total time of the journey is calculated as 120 divided by 60, which is 2 hours. Now, time for first part is 1 hour, and for second part is 90 divided by x. We have to calculate x. Hence, 1 plus 90 by x equal 2. Hence, x is 90 kilometers per hour. In this problem, we have a train traveling with 3 different speed for 3 parts. Of the journey, we have to calculate average speed of the train. A train travels at a speed of 60 kilometers per hour for 0.52 hours, at 30 kilometers per hour for the next 0.24 hours, and at 70 kilometers per hour for the next 0.71 hours. What is the average speed of the train? For average speed, we have to calculate total distance and total time. Here also, we will use speed formula to calculate distance traveled. Speed equal to distance divided by time, or distance equal speed into time. Hence, we will calculate distance of each part of the journey and will sum all 3 to get total distance. Now, total distance is sum of all three part of the travel, which is 88.1 kilometer, and total time is also sum of all three time, which is 1.47 hours. Hence average speed is 59.9 kilometer per hour. Here, we will learn about velocity. Velocity is defined as displacement divided by time taken. Note that speed was distance divided by time. Recap the definition of displacement and distance. The C unit of velocity is the same. That of speed, namely meters per second. The difference between speed and velocity is that speed has only magnitude or size. It has no specific direction, but velocity has magnitude as well as direction. In fact, velocity of a body is its speed in a specified direction. Speed is scalar quantity and velocity is vector quantity. In this example, we will see average velocity and average speed. Remember, for average speed, we have to calculate total distance and total time. And for average velocity, we have to calculate displacement and total time. Here you can see Yush or swims 90 meters one way. Hence, total distance equals 90 plus 90 equals 180 meter. but total displacement is 0, as her initial and final position is same. Hence, average speed equals 180 divided by 60 equals 3 meters per second, and average velocity is 0 divided by 60 equals 0 meters per second. In this example also, we will calculate speed and velocity. Suppose the boy first runs a distance of 100 meters in 50 seconds in going from his home to the shop in the east direction, and then runs a distance of 100 meters again in 50 seconds in the reverse direction from the shop to reach back home from where he started. Calculate speed and velocity. For average speed, we have to calculate total distance and total time. And for average velocity, we have to calculate displacement and total time. Here you can see boy travel 100 meters one way, hence total distance equals 100 plus 100 equals 200 meter. Total time equals 50 plus 50 equals 100 second, but total displacement is 0, as his initial and final position is same. Hence average speed equals 200 divided by 100 equals 2 meter per second, and average velocity is 0 divided by 100 equals 0 meter per second. Here, we will learn about acceleration. When the velocity of a body is increasing, the body is said to be accelerating. Acceleration of a body is defined as the rate of change of its velocity with time. Hence, acceleration is change in velocity divided by time. It is v minus u divided by t, where v is final velocity and u is initial velocity and t is time taken for change. Hence, acceleration is the rate of change of velocity. The SI unit of acceleration is meter per second square. Here, we have to calculate acceleration of a moving body when initial and final velocity is given. Initial velocity is 80 kilometers per hour and final velocity is 60 kilometers per hour. Remember to convert the unit of velocity from kilometers per hour to meters per second. It is 5 divided by 18. Hence, acceleration is calculated as change in velocity divided by time. Here, we get negative value, mean it is a deceleration. Here, we have to calculate acceleration of a moving body when initial and final velocity is given. Initial velocity is 0 and final velocity is 6 meters per second in first case. Time taken is 30 seconds. Hence, acceleration is calculated as final velocity minus initial velocity divided by time taken. Hence, acceleration is calculated as 0.2 meter per second square. Second case is calculated in next slide. Here, we have to calculate acceleration of a moving body when initial and final velocity is given. Initial velocity is 4 meters per second and final velocity is 6 meters per second and time taken is 5 seconds. Hence, acceleration is minus 0.4 meters per second square. Negative sign means it is deceleration.